When we have to solve linear programming problem, basically we have two methods. One method is known as graphical method, the other method is known as simplex method. In linear programming problem, the first step, as we have discussed, the formulation of the problem based upon the data provided to us, which is relevant to the real life situation or organizational context. So formulation of the problem is very, very important, because whatever the solution we obtain based upon that problem only, whatever the equations we have written down or noted down are based upon the realistic situation. Then we have to draw or we have to write the constraints also, the limitations which are associated with that situation, and then we have to find out a graphical region which we call that as feasible region for the solution. How we are going to do that? When several constraints are given, something like less than or equal to 0 or something like greater than or equal to 0. Likewise, we might have several constraints that are associated with a problem. So there is a limitation on the availability of raw materials. Then we say that equation will result in less than or equal to certain number of kgs of raw material. And similarly, there is a restriction on certain number of machine hours. Then it is also an equation which will result in lesser than or equal to. Or there is a minimum demand for a certain product where there is a commitment to supply certain number of units. Then it will result in greater than or equal to certain number of units. That will come as an equation. So what we are trying to do is, in graphical situation or graphical solution method, we equate all those inequalities, or we convert inequalities into equalities, or then they become equations. Once they become equations, we will because graphical method only can solve two variable problem. When we look at the graph, we have only two axes, that is x-axis and y-axis, where two variables can be represented. So we give arbitrarily 0 value to one variable in that equation, and we try to find out the value of other variable. Then after obtaining the value of other variable, that we will substitute in the equation and try to find out the another variable value. So these values are used to draw the lines on the graph sheet. So if there are 5 constraints, it will result in 5 lines. Or if there are 3 constraints are there, that will give us 3 lines. So once we have drawn those 3 lines, as it has shown in the graph, we will find some region which is hatched region, or that we call that as feasible region for the problem or for the solution. So for the problem, then what we try to do is, we will try to identify the extreme points, right? Then we try to find the solution. So wherever those lines are cutting, so in case if the equation is greater than 0, the feasible region lies above that. If it is less than or equal to equation, when we have drawn the line, the region below that line will be part of the solution. So likewise, we have got some region which is hatched by. So that is the way we have obtained the feasible region. Then in this we have extreme point method, which is also known as corner point method for this feasible region. When we have to obtain the solution or the optimum solution, whether that might be minimization problem, whether that might be maximization problem, we have to obtain the optimum solution. That means which serves the organization better. In minimization case, it should be the lowest value. In case of maximization, it should be the highest value. What will, after finding that feasible region, we identify usually by observation or by looking at that, we will see what are the extreme points in that region where we can identify. Those points are given like A, B, C, D, E or some names we will be giving, and we identify the coordinates for each of these extreme points, and those are the solution points. Those extreme points or corner points are the solution points for a given problem. Then we will find out x coordinate and y coordinate for each of the points, and they will be substituted in the equation. So what is that equation? That objective function. Because we have written that objective function, whether that may be minimization or maximization. Say we will write like this: point objective function value. So under point A, B, C, D, E, then objective function we have written z is equal to, or z is equal to this equation. We will substitute those values and we will find the value. So if it is a maximization, then for all these 5 points or 4 points, whatever the number of points we have obtained, whichever gives us the maximum value, that is the solution that we find. So that is extreme point method. That is how we try to identify optimal solution based upon maximization or minimization. And similarly, we have and as we have discussed, graphical method is only applicable to 2 variable problem. That means if there are 2 variables, then only it can solve the problem. If there are more than 2 variables, they cannot be represented on a graph or graphical method, and it is not possible to find a solution.
And now we will draw the line. Oh, this line here. अरे थोड़ा सा Now we'll see this portion as hashed portion as is done. Which we call this as feasible region. This is feasible region, this entire region. Starting from origin, we call this as feasible region. And this equation, okay, this is 2 8x1. Okay. This equation is 8. This line represents 8x1 plus 4x2 is equal to 80. And this line represents 2x1 plus 3x2 is equal to 30. And this line represents x1 is equal to 6. This line represents x2 is equal to 8. So what actually it means is, for all values of y, x1 remains same. That is the reason it is a straight vertical line. For all values of x, x2 remains, or y value remains same. That is the reason. These are the points that we have connected by finding the x1 and x2 values as we have calculated in the problem. So this region, this hatched region, is known as feasible region. So we call that as feasible region. Feasible region. So I'll write down here feasible region. In this feasible region, we will identify the solution points. This is O, this is A, this is B, this is C, this is D. And we have found out the coordinates based upon these values, and we have found out the solution. As per the solution, we'll check that and see which point should be the solution point. So this is the graphical method. But always we should remember that, and how we have decided this region is, we have all constants less than or equal to. Less than or equal to indicates the solution lies behind this, or below this. Solution lies below this, because there should be less than values, right? Likewise. So for this line also, actually indication is less than. This means this is the way. For this also it is a less than. So this feasible region, for this also it is like this. So what it indicates? It is this area is only common area for all these lines, for all these values. That means it is satisfying every constraint, every limitation has been satisfied. That is the reason we identified this region. So that is how we have found out.